Hi friends, just wanted to make a quick little video since I got the boosted LS apart here. I guess a 10-minute tech tip video. LS boosted engine building basics. This thing started out as a 6-liter. Now it is a 6.7 or 408 cubic inch engine. And the reason for that is because I got a stroker crankshaft in here. Lunati forged unit 4340 with H-beam rods. Of course, we've got our nice forged pistons. These are actually Summit brand pistons built for boost, but it's actually a Wiseco product. So Wiseco makes these for Summit, so that's a 1218 part number. Really nice pistons, as you can see. They got the valve reliefs, fantastic. Let me just flip this thing over, show you the bottom end and the rotating assembly. That was prepared by LSX Acceleration out of Tennessee. Real good guys down there, as you can see here. So we got our H-beam rods, beautiful. We got a fully studded bottom end. So when they line honed these fasteners were used. You have to use, whenever you're doing a machining procedure, guys, you got to use the same fasteners that you're going to use in the block upon assembly. So as you can see here, you give them the fasteners, then they do all the machining, okay? That goes for the heads too. So make sure you do that. Again, we got, this is all ARP stuff. We got the studs. And we got, of course, the good 7/16 rod bolts here. And again, H-beam rods, 4340, everything's balanced, so that's nice. And yeah, so that's where you want to start. You might as well spend the money right away, guys. Get yourself a forged rotating assembly if you're building an LS for boost, because, you know, you can get away with the stock shit, which actually works really good. But if you want to have longevity and you don't want to do it again, just get the right shit right away. All right, I'll flip this thing over so you can see the top end again. So I just got these studs in here for demonstration purposes, guys, because when this block was initially machined, when I did the bore, it's a 4.030 bore. So yeah, 4.030 with a 4-inch stroke gives you 408 cubic inches. So I just got these in here for demonstration purposes, guys. If I were to do it again, I would have did this right away with the studs because they have way more holding power. For example, this is an 11 mil stud right here. So the bottom of the stud is a coarse thread and the top is a fine thread. So fine threads, when you put the nut on there, it exerts way more clamping force. So for example, 11 mil is basically a 7/16, or it's equivalent. So if I'll just give you a little sample here. So 14 threads per inch on a 7/16 versus approximately 20 on the fine thread end of things. 14 threads per inch would provide for about 6,000 pounds clamping force. And as soon as you put that nut on there on a fine thread, well, it provides for about 10,000. So you can see it's a 40% increase in clamping force or hold. So get the studs right away, and then you'll be fine. You won't blow head gaskets. It's just a stronger system, especially when you're talking about boost. So yeah, I didn't do that, so I'll be putting the bolts back, as you can see here. Because again, when they torque plate honed this to 4.030, they used a torque plate to simulate the cylinder heads over there. Because it distorts the block, well, as it would be when the heads are back on there. So it keeps the cylinders perfectly round. So if I use different fasteners, it would distort it or move it in a different way. It won't be a perfect seal, but again, since this block was machined with torque plates using bolts, that's what I'm putting back. I just have these in here for demonstration purposes. I'll be taking them out. So anyways, guys, yeah, so that's what you want. You want to always machine your block with the fasteners you're going to use in your build. And another thing I didn't do last time, I had the decks machined nice and flat, but I just used the heads as is. But now they've been machined 3 thou, each, 3 thou off the deck to ensure complete flatness. We've also got new gaskets here, the chromatic MLS multi-layer steel. These are also 4.030. What I used before is I used gaskets right over here. They were 4.060, so they were a little bit bigger than a bore, so there's like a little step there. So you want to avoid that step, guys, because as soon as you have a step, you basically have a space, or like if there's a little step here underneath the head, so it kind of fucks up your quench area. Plus there's a space, and it's not exactly a perfect bore anymore because, 4.030, the ones over there, they're the right size. It basically, there's a spot for a boost leak. So you want to try to get the same size gasket as your bore in most cases. So yeah, so we're putting the new ones on, and always use new gaskets. Don't fuck around with used shit like I did. Like, you see this? They're good, but again, if you're doing a build, get your decks machined from the block, get your heads machined flat, especially if it's a boosted application, and you're going to seal with new gaskets. You shouldn't have any problems if you use bolt or studs. All right, guys. So yeah, so that's what we'll be doing. Again, Ford's rotating assembly, Ford's pistons, everything's balanced. Use studs right away. You got to spend a bit more money, but if you want to have an engine you don't want to fuck with in the future, get the right shit first. So again, we'll be taking these off just for demonstration purposes. I'll be putting my bolts back because, again, the torque plate was done with bolts, not studs, because it stresses the block differently. So we're going to be putting those bolts back, which should be fine now since the decks have been machined 3 thou off each head. So again, guys, 3 thou off each head. These are 17s. So yeah, 3 17s. So a 71 combustion chamber. So it affords, with these pistons here, our static compression ratio is 9.3. So let's just say they took 3 thou off each head. So basically it's around 70. So it might be 9.35 static, so which is fine. So that's a nice compression ratio. You know, it's not too low, so it's not a complete dog out of the hole with no boost. So yeah, so 9.3 approximately. So it might be a little bit higher now, since like I said, they machine about 3 thou off each head. So that's flat. We got new gaskets, and we'll put this thing back together again, and hopefully she should be good for next season. I just have this apart just because I wanted to check everything, make sure everything was okay. Looks like it is, so that's nice. All right, guys. And yeah, so I got the water pump. I had to modify this to fit. You can see my stuff here. So here's the water pump, new one. Finally got a new one. This is the old one that was leaking. So we're gonna put the new one in. Here's our turbocharger right here. It's a 7576 billet wheel on 3 Chinese turbo. So it actually did really well using a factory intake over there. My custom air cleaner assembly stuff. I should actually post some pictures of that, how that all works. But anyways, yeah, so I'll make another video shortly. Here's my oil pan gasket and other stuff, my boost piping, cold side, hot side, and yeah, so I'll make another video in the future when the heads are on, and we can get some further updates. So I just took this apart, took it out just to make sure everything was okay. And again, I didn't machine the heads last season, which I should have done, you know, taking shortcuts. Used gaskets, which I shouldn't have done, right? And initially when I built this thing, I should have used studs right out of the hole, which I didn't do, but I should have. So anyways, guys, yeah, so use the fasteners. The point of this video is use the fasteners, get the good ones right away. So main studs, head studs, and then get your engine machined appropriately. So yeah, so we'll be taking these off, putting our bolts back. So, and also guys, yeah, so this is the car it's going into. 1984 Thunderbird, basically a Fox body or a Mustang. Thing hooks up awesome because I got a whole bunch of, well, you can see the frame connectors right there. So everything is solid and rigid because these things twist like crazy, Fox bodies, so everything's solid and rigid. I got some outriggers here, and I've got some expanded metal. Basically, we've got a epoxy impregnated into the spaces here, so it's super stiff because I didn't like the idea of a cage. And everybody's wondering why I'm hooking up so well. Well, this is why. So I'm kind of giving away a little bit of secret now, but that's okay. It's all fun. So I'll show you the underneath here, guys, if you're still with me. Yeah, so we've got a Team G double adjustable 4-link here. So that's another reason this thing hooks. Okay. Plus it's a Fox body, right? So that's the reason these things hook up so well. And I got a custom 4-wheel disc system I built here. So this is basically a Ford Explorer rear end out of a 97 Explorer. So you can see here, there's a disc brake. I took the whole rear end and I water jet cut a plate. I don't know if you, well, you can't, yeah, see that plate right there, guys? So I water jet that, welded it to the axle, and I took the hardware from a 97 Ford Explorer, the disc brake hardware, and I just transferred it to the 8.8 rear end from a Fox body, because the Fox body, our Mustang from that year, didn't have disc brakes. So I made my own disc brake rear end out of 2 different rear ends. So yeah, works really well, guys. Since I'm down here, I'll show you the MagnaFuel fuel pump right here. This is a Pro Tuner 750, number 10 coming out of the tank. There's the fuel pump. So we got some good shit in this car, guys, and it works really well. You know, along with that engine, people were surprised. So next year should be better, right, guys? Anyways, friends, thanks for watching. Just wanted to make a quick video here. Took this out just to check it. And thanks for watching. Thanks for subscribing. I haven't got many subscribers lately because I haven't made any videos, but going forward I will. So anyways, guys, thanks for your support. Until the next time, till we make another video. Appreciate it.